Okay, in the last class, we started with nuclei topic. So in the nuclei topic, we discussed like what all the content or the constituents of the nucleus is there, what are the different types of forces we have. Then after that, we discussed different types of nuclei and examples for that. Then discovery of the neutron. So decay law, that is nuclear radioactive decay law, radioactivity phenomena. Then the structure of the nucleus we discussed. So the radius of the nucleus, what is the formula, and like mass defect, binding energy. So these are the contents which we discussed in the last class. So today we will see some formulas and we are going to begin with the MCQs of both atoms and the nuclei. So first we are going to see the atoms topic nuclear MCQs questions. So in that you can see here, first what we are seeing, ನಿನ್ನೆ ನಾವು decay log stop ಮಾಡಿದ್ವಿ. So the radioactive decay law is given by n is equal to n e raised to minus lambda t. So here n of t is nothing but that is number of yesterday radioactive decay law ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ, the rate of disintegration is directly proportional to the number of atoms in the initial stage. ಅಂದ್ರೆ ಇನಿಷಿಯಲಿ ಎಷ್ಟು ನಂಬರ್ ಇರುತ್ತೆ ಅದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ ರೇಟ್ ಆಫ್ ಡಿಸ್ಇಂಟಿಗ್ರೇಷನ್ ಅಂತ ಹೇಳಿದ್ವಿ. ಸೊ ಹಿಯರ್ ವಿ ವಿಲ್ ರೈಟ್ ಇಟ್ ಆಸ್ dn by dt is equal to minus lambda into n naught. So here minus sign is indicating the number of atoms is decreasing with the time, and the negative sign shows that the decrease in the number of atoms with respect to time it is showing. Okay, so lambda ಅನ್ನೋದು decay constant ಇದೆ. So lambda is the decay constant here. So this all we have discussed in the last class. So what we are going to see today is the next part, that is the half life and the mean life we are discussing. So what is half life here? You'll notice the half life of a radioactive substance is the time in which one half of its nuclei will disintegrate. It is inversely proportional to the decay constant of the radioactive substance. So half life annodeniде, this half life is the time in which one half of its nuclei will disintegrate. So ನಿಮ್ಮ ಹತ್ರ ಏನೋ ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅದ್ರದ್ದು ಹಾಫ್ ಆಗ್ಲಿಕ್ಕೆ, ಸೊ half of the value, for example suppose you have the number of atoms like 10 atoms you have, ಅದ್ರದ್ದು half ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ, 5 ಆಗುತ್ತೆ. So to become that much, how much time it is taking, that is called as the half life. Okay, that is given by T half is equal to, we have the formula here, you can see T half is equal to 0.693 divided by lambda, where lambda is called as the decay constant. Lambda is called as the decay constant. Okay, then the next point, mean life. So half life is clear. Let us see what is mean life. Mean life is nothing but the mean life of a radioactive sample. It is defined as the ratio of the combined age of all the atoms and the total number of atoms in the given sample. So the total number of atoms in the given sample ಮತ್ತೆ ಅದರದ್ದು average. So ಅದನ್ನ ತೆಗೆದಾಗ ನಮ್ಗೆ ಏನ್ ಸಿಗತ್ತೆ ಅಂತಂದ್ರೆ mean life ಸಿಗತ್ತೆ. Or you can also take this mean life as tau is equal to T half upon 0.693. Or you can also write it as 1.44 into T half. 1.44 into T half. This is the mean life. So half life formula, mean life formula. Here you can see both the formulas. Here one conversion factor we have, that is the SI unit of this decay. So illen atoms decay ಆಗ್ತಾ ಇದೆ, ಇದ್ರ SI unit ಕೊಟ್ಟಿದ್ದಾರೆ. The SI unit of this decay is given by, it is Curie. So we express in terms of QD. So here 1 Curie is the decay rate of 3.7 into 10 to the power of 10 disintegrations per second. So 1 Curie is the rate of decay rate of 3.7 into 10 raised to 10 in disintegration per second. That is called as the 1 Curie. What do you mean by Rutherford C? 1 Rutherford is the decay rate of 10 raised to 6 disintegration per second. So Rutherford is also the unit of the decay here. So Curie ಅಲ್ಲಿ express ಮಾಡ್ಬೇಕಾದ್ರೆ Curie ಅಂದ್ರೆ 1 Curie ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ, 3.7 into 10 raised to 10 disintegration per second. Rutherford andre here, that is nothing but the rate of 10 raised to 6 disintegrations per second is called as the Rutherford. Okay. Then next, natural radioactivity. So what is natural radioactivity? See, it is the phenomena of the spontaneous emission of alpha, beta, and gamma radiations from the nuclei, which is naturally occurring isotopes. So this phenomena is called as natural radioactivity. Artificial radioactivity, here we induce this phenomena. So now we'll phenomena na induce ಮಾಡ್ತಾ ಇದೀವಿ, that is called as the artificial or the induced radioactivity. So nuclear fission, fusion, yesterday we have discussed this point. Okay, now we are going to see the multiple choice questions on the atoms topic. Yes. So here we have the first question. The atomic number of silicon is 14. Its ground state electronic configuration is. So here silicon atom is given. So for silicon, the atomic number is, that is 14. Then what is the ground state electronic configuration? So in chemistry, you might have studied about the electronic configuration. So based on that, we need to write this one. The ground state electronic configuration of silicon. Options given are, that is 1s2, 2s2, 2p6, 3s2, 3p4. So first count ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ, 4, 2, 6, 6 plus 6, 12, 12, 14, 16. Option A is not there. B, 3, 2, 5, 5 plus 6, 11. No. So option C, 2, 2, 4 plus 6, 10 plus 2 plus 2, 14. Then option D, 2 plus 1, 3, 6 plus 3 is 9, 9, 10, 11, 12, 13. Yes. So option C is the correct option. That is 1s2, 2s2, 2p6, 3s2, 3p2. So option C is the correct option here. Then the next question, what is the valence electron in alkali metal? What is the valence electron in alkali metal? So given options, F electron, P electron, S electron, D electron. So the valence electron in the alkali metal is, as we know that it is 1, correct? So alkali metals ಅಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ, 1 ಇರುತ್ತೆ. So therefore we can say it as S electron. Okay. Next question. Of the following pair of species, which one will have the same electronic configuration for both members? That is lithium plus sodium plus, helium and neon plus, hydrogen and lithium, carbon and nitrogen plus. Yes, students, which one will come? So lithium is 3, sodium is 11, helium is 2, neon is 10. Of the following pair of species, which one will have the same electronic configuration for both members? ಸೊ ಕೊಟ್ಟಿರೋ ಪೇರಲ್ಲಿ ಎರಡುದ್ರದ್ದು ಏನ್ ಸೇಮ್ ಇರ್ಬೇಕಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ದಟ್ ಇಸ್ electronic configuration. So hydrogen and lithium, no, C baralla. Option B is also not possible. And options A is out of A and D. So here carbon is having 6, so nitrogen is having 7, but N plus they are giving. So therefore here among the following, that is option D, they have the same configuration as they are giving the nitrogen plus. Therefore, carbon and nitrogen have the same electronic configuration. Then the next question. Which of the following did Bohr use to explain his theory? Options: conservation of linear momentum, the quantization of angular momentum, conservation of quantum frequency, conservation of mass. So here the Bohr will use, according to Bohr's postulates, I'll note TV. According to the Bohr's second postulate, the angular momentum is equal to integral multiple of h upon 2 pi anta ಹೇಳ್ತಾರೆ. So that is nothing but what? Quantization of angular momentum. Quantization of angular momentum. Option B is the correct option here. Then the next question. According to Bohr's principle, what is the relation between principal quantum number and the radius of the orbit? So here options: R is proportional to 1n, R is proportional to 1n square, R is proportional to n, and option D, R is proportional to n square. Okay. So according to Bohr's principle here, R is proportional to n, that is option C is the correct option. That is from the energy relation you can see. So energy derivation ಅಲ್ಲಿ ನೀವು ನೋಡಬಹುದು. That is the n term will come in the denominator, therefore sorry numerator. R is proportional to n ಅಂತ ಹೇಳ್ಬೋದು. Then the next question. The kinetic energy of the alpha particle incident on the gold foil is doubled. The distance of closest approach will be doubled. So the statement is true or false. So what is the question here? The kinetic energy of the alpha particle incident on the gold foil is doubled. So kinetic energy double adaga, the distance of closest approach will also be doubled anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So whether it is true or false, that we need to see. Here, as the kinetic energy is doubled, the distance of closest approach will be reduced to half. The distance of closest approach will be reduced to half here. So here they are inversely proportional. So twice adre ali 1/2 anta agutte. Therefore it is a false statement. Then the next question. Based on the Bohr model, what is the minimum energy required to remove an electron from the ground state of barium atom? So for the barium atom, Z is equal to, it is 4. So for the barium atom, not for the, okay. You can use minus 13.6 into Z square divided by N square formula. So let us see and substitute what you are going to get it. So which orbit they are saying, what is the minimum energy required to remove an electron from the ground state? Andre N is equal to 1 agatte of the barium atom. So Z square divided by N square into 13.6 we need to do here. So see the solution. E is equal to 13.6 into z square by n square. So it is 4 square is 16 divided by it is 1 square. So 13.6 into 16, that is nothing but 217.6. That is option D is the correct option. Then the next question. If an alpha particle collides head on with a nucleus, what is its impact parameter? If an alpha particle collides head on with a nucleus, what is its impact parameter? So options 0, infinity, 10 raised to minus 10 meter, it is 10 raised to plus 10 meter. So see here, the impact parameter will be 0. So why it is 0? Because here what happens, the perpendicular distance between the path of the projectile and the center of the projectile is called as impact parameter. So impact parameter andre enagatte, distance between the path of the projectile andre yav path al travel ಆಗ್ತಾ ಇದೆ and the center of the potential field. ಆದಿ ಎರಡು ಮಧ್ಯದ ಡಿಸ್ಟೆನ್ಸ್ ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದೇನಾಗ್ತಾ ಇದೆ, ಕೊಲಿಷನ್ ಹೆಡ್ ಆನ್ ಕೊಲಿಷನ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಹೆಡ್ ಆನ್ ಕೊಲಿಷನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಹಿಟ್ ಇಟ್ ಡೈರೆಕ್ಟ್ಲಿ. ಸೊ ದೇರ್ ಫೋರ್ ಹಿಯರ್ ದ ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ 0. ಆಪ್ಷನ್ ಎ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. Next question. In which of the following system will the radius of the first orbit be minimum? Options: doubly ionized lithium, singly ionized helium, deuterium atom, hydrogen atom. So here when will the radius of the first orbit be minimum? So yav condition alli radius will be minimum anta kelta idare. Options: doubly ionized lithium, singly ionized helium, deuterium atom, hydrogen atom. That is option A correct agide, doubly ionized lithium. That is for the first orbit, the energy, the radius of the first orbit will be minimum anta helbodu. That is option A is the correct option here. Then the next question, an alpha particle of energy 10 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. Calculate the order of distance of the closest approach. An alpha particle of energy 10 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. Calculate the order of distance of the closest approach. Here the closest approach, how we can calculate, see the energy is given as 10 mega electron volt and the angle is given as 180 degree. We need to calculate the distance of closest approach. So see how to use this. That is nothing but kinetic energy is equal to 1 upon 2 pi epsilon naught ZE into 2E divided by D, which is equal to So here the energy of the particle is given as 10 mega electron volt. So 10 into 10 raised to 6 plus 6, 10 into 10 raised to 6 electron volt. So electron volt ಅಲ್ಲಿ ಇರೋದನ್ನ joules ಅಲ್ಲಿ convert ಮಾಡ್ಕೊಳ್ಳಿ. That is nothing but 1.6 into 10 raised to minus 19 is equal to, here it is 9.10 raised to 9 into Z is 235 into 2 into 1.6 whole square into 10 raised to minus 19 whole square. So is it clear, students, what we are doing here? The distance of closest approach is nothing but d value in this formula. So d kinetic energy is equal to 1 upon 2 pi epsilon naught Ze into 2r upon 2e upon d. Okay, so kinetic energy or energy is given as 10 mega electron volt. So 10 mega electron volt can be written as 10 into 10 raised to plus 6 electron volt ಅಲ್ಲಿ ಇದೆ joule ಅಲ್ಲಿ ಮಾಡಬೇಕಾದ್ರೆ 1.6 into 10 raised to minus 19 ಆಗುತ್ತೆ. Substitute the remaining values. So it is 9 into 10 raised to 9, 235 into 2 into 10 raised to 6 into 10 raised to minus 19 whole square divided by d. So here we need to simplify this equation for d is equal to. So फिर इसको d, take this d here, write this all numerator term like 9 into 10 raised to 9 into 235 into 2 into 10 raised to 1.6 square to minus 5 and divided by, here see, 10 into 1.6 into 10 raised to minus 19 minus, sorry, plus 6. So 19 ಅಲ್ಲಿ 6 ಹೋದ್ರೆ plus minus 3 ಆಗುತ್ತೆ. So minus 3 ಉಳಿಯುತ್ತೆ. Then 10 into 1.6. 16. So therefore here it becomes 16 into 10 raised to minus 16 into 10 raised to plus 3. Okay. Now you substitute that d change ಮಾಡ್ಕೊಳ್ಳಿ. So d ಈ ಕಡೆ ತಗೊಳ್ಳಿ ಮತ್ತೆ